Okay, so now we can talk about some specific formulas that we have that we call our sum and difference formulas. And that is exactly what they really are. When we say sum and difference formulas, we really mean sums and difference. So now what we're going to look at is that we have four formulas we need to consider. The cosine of the sum of two angles, alpha plus beta, which is cosine alpha cosine beta, minus sine alpha sine beta. You have cosine of alpha minus beta, which is cosine alpha cosine beta plus sine alpha sine beta. And sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. And sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. So notice that for cosine, they're always together, cosine, cosine, sine, sine, and that if we have a plus on the left-hand side, it goes to a minus in our formula. A minus left side plus the right side. For sine of alpha plus beta and alpha minus beta, if there's a plus on the left, there's a plus on the right. The only difference is they're mixed. So sine alpha cosine beta, cosine alpha sine beta. And for minus, it's minus and minus, and it's just still the same, sine alpha cosine beta minus cosine alpha sine beta. So let's see how we can do stuff here. So we have cosine of 45 minus 60 degrees. So we have a subtraction. So with our subtraction of cosine 45 minus cosine 60, this is going to be cosine 45 cosine 60 minus, plus sine 45 sine 60. Well, we know what cosine of 45 and sine of 45 is, so that's our square root of 2 over 2's in each case. Cosine of 60 degrees is going to be 1/2. Sine of 60 degrees is going to be square root of 3 over 2. So we end up with square root of 2 over 4 plus square root of 6 over 4. And we could rewrite this as root 2 plus root 6 all over 4 if we really wanted to. Since it says find an exact value, we do not want a decimal. We do not want any approximations. We want to leave it just like that. So now we're told to write the expression as the cosine or sine of an angle and find the exact value. So in this case, we have cosine, cosine. So that means we're either cosine alpha plus or alpha minus. We have a plus in there, so that's going to be a subtraction. So therefore, this becomes cosine of 96 minus 36, which is cosine of 60 degrees. So that is the writing the expression. Cosine of 60 degrees we just talked about is 1/2. So again, we're told just now we're going to be working in radians instead of degrees. So it's sine and cosine, so it's mixed. That means we're either sine alpha plus beta or alpha minus beta. We have a plus sign right here. So the plus for sine of alpha plus beta, so that's we're going to add. So this is sine of 5 pi over 12 plus pi over 4. This is going to give us sine of 8 pi over 12. which is the same as sine of 2 pi over 3 by reducing the fraction. So 2 pi over 3, the sine is square root of 3 over 2. So we're told, use a sum or difference identity to find the value of sine of 180 plus 30. So it's a sine and plus. So this is sine 180 cosine 30 plus sine 30 cosine 180. Sine of 180 degrees is 0 times cosine of 30 is square root of 3 over 2. Plus the sine of 30 is 1/2. Cosine of 180 is -1. So we get 0 minus 1/2. So we get -1/2 is our answer here. So now we're not given anything for our starting piece. So what that means is we have to come up with what we need to do here. So cosine of 75. So anytime we see this, we want to look at that angle of 75 and we want to know what are some angles that we know that can either add up to 75 or that can subtract down to get us to 75. Well, the two that I see real quick is going to be 45 plus 30. Both of these we know angles form. In other words, don't write something that you don't know the if it's not on your unit circle, basically. So cosine of alpha plus beta is cosine 45 cosine 30 minus sine 45 sine 30. So cosine of 45 is root 2 over 2. Cosine of 30 is square root of 3 over 2. Sine of 45 is root 2 over 2. Sine of 30 is 1/2. So we get square root of 6 over 4 minus square root of 2 over 4, or root 6 minus root 2 all over 4 would be our answer here. So far we've talked about sines and cosines. Now we can talk about tangents. So tangent of alpha plus beta is equal to tangent of alpha plus tangent of beta over 1 minus tan alpha tan beta. Whatever the sign is in the parentheses, that's the sign that goes up top. The one down below is opposite always. So tangent of alpha minus beta is tan alpha minus tan beta over 1 plus tan alpha tan beta. Now the question is, how can we prove these knowing what we already know? Well, it's easy. Break tangent down to sine and cosine. If you already know sine of alpha plus beta and cosine of alpha plus beta, divide the two and you know tangent. Same thing with sine alpha minus beta, cosine alpha minus beta. So we already know how we can do it. It's just a matter of, do we want to use this formula or this formula, or do we want to use something we already know? If you don't already know cosine of alpha plus beta, sine of alpha plus beta, or cosine alpha minus beta and sine of alpha minus beta, it makes no sense to use those. We use these formulas and we're done. It all depends on what the problem asks us for here. So we're told, find the value without a calculator. So what we want to do here is we need to plug into our formulas. So tangent of alpha minus beta. So this is going to be tangent of 7 pi over 6 minus tangent of 7 pi over 4, all divided by 1 plus tangent of 7 pi over 6 times tangent of 7 pi over 4. So tangent of 7 pi over 6. So the tangent of that is going to be, let's do a little side work here. So tangent of 7 pi over 6 is equal to -1/2 divided by -√3 over 2. So that's 1 over square root of 3, which is the same as square root of 3 over 3. So we have square root of 3 over 3 minus the tangent of 7 pi over 4 is going to be -1. Because anything that has 4s in it is either 1 or -1, depending on the quadrant. 7 pi over 4 is in the 4th quadrant, so therefore its tangent is negative. For the denominator, we have 1 plus square root of 3 over 3. Tangent of 7 pi over 4 is -1. So if we simplify this, we actually have √3 over 3 plus 1 all over 1 minus √3 over 3. I'm going to multiply everything by 3 over 3 to get rid of my fractions inside of fractions. So we get √3 plus 3 over 3 minus √3 as our answer here. Normally when it says without a calculator, I want to see all this work, and we want to leave it in fractional form with no fractions inside of fractions, but radicals are okay. So we're told, write the expression as the cosine, sine, or tangent of an angle and find the exact value. So we know we have a plus up top. So that means that this is in the form of tangent of alpha plus beta. So in this case, this is tangent of 25 plus 20, which is the tangent of 45. The tangent of 45 is just 1. So now we're going to have to start drawing some diagrams or drawing a triangle to see where we're at. So we're told, find the exact value of cosine of alpha plus beta, sine of alpha plus beta, and tangent of alpha plus beta underneath the following conditions. So first one we're going to draw is going to be alpha. So sine of alpha is 15 over 17. So that means that my third side here is 8. It's in quadrant 1, so everything is positive there. The next we can find is beta. So sine of beta, actually I'm going to draw it like it says it over here. Beta lies in quadrant 2. So the sine of beta is 4 over 5. So that means that this last side is a -3. So we gotta pay attention. These quadrants will tell us the signs, positive or negative for certain things. So now if we come back over to our formula here, we're told we want to find cosine alpha plus beta. So we'll find that one first. Cosine alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. So cosine of alpha is 8 over 17. Cosine beta is -3/4. Sine of alpha is 15 over 17. Sine of beta is 4 over 5. So we end up with negative 6 over 17 minus 12 over 17. So that gives me negative 18 over 17 is the cosine of alpha plus beta. Double check and make sure. So I was doing all that in my head right there. So now we want to do sine of alpha plus beta. So we have sine alpha cosine beta plus cosine alpha sine beta. So sine alpha is 15 over 17. Cosine beta is negative 3/4. Cosine alpha is 8 over 17. And sine of beta is 4 over 5. So we're left with negative 45 over 68 plus 32 over 85. Just double check that. All right, so if we type that in, we get a really ugly number, negative 97 over 340. All right, so I made a mistake here. So cosine of beta is actually negative 3 over 5. So that's going to be negative 24 over 85. So minus 12 over 17. So this is negative 84 over 85. Cosine beta is negative 3 over 5. Okay. So there we go. Negative 13 over 85. So since we found our sine and cosine here, to find our tangent of alpha plus beta, that's literally just sine of alpha plus beta over cosine of alpha plus beta. So we get negative 13 over 85 divided by negative 84 over 85. So we get 13 over 84 as our answer here. We got to be very careful when we start plugging these in and everything. That proves it right here with this mistake that I just made and everything. So always make sure that we are plugging in everything to the exact spots and everything to make sure. So same style problem, just we're giving it in a slightly different way now. So let's draw it out before we even get started. So alpha is between pi and 3 pi over 2. So that means that we are in the fourth or third quadrant. So if this is my alpha, so tangent is 1 over negative or negative 1 over negative 2, which means that this is square root of 5. Cosine of beta is in the fourth quadrant. So cosine of beta is 3 over 5. And this would mean this would be negative 4. So to find cosine of alpha plus beta, so that's cosine alpha, cosine beta minus sine alpha sine beta. So cosine of alpha is negative 2 over root 5. Cosine beta is 3 over 5. Sine of alpha is negative 1 over root 5. Sine of beta is going to be negative 4 over 5. So that's going to give me negative 6 root 5 over 25 minus 4 root 5 over 25, which is negative 10 root 5 over 25, which is negative 2 root 5 over 5 when we reduce. Next, we're going to do sine of alpha plus beta. So that is a sine alpha cosine beta plus cosine alpha sine beta. So sine of alpha is going to be negative 1 over root 5. Cosine beta is 3 over 5. Cosine alpha is negative 2 over root 5. Sine of beta is going to be negative 4 over root 5. So this is going to be negative 3 root 5 over 25 plus 8 over 5. Oop. Sine of beta should have been negative 4 over 5. Sorry about that. So this is going to be 8 root 5 over 25, which is 5 root 5 over 25, which is root 5 over 5. We want tangent of alpha plus beta. We'll do this one two ways just to show it to you. So it's sine, so that's going to be √5 over 5 divided by -2 √5 over 5, which is going to be √5 over -2 √5, which is -1/2. So the other way that we could do this is if we use our formula. So tangent of alpha plus beta is tangent of alpha plus tangent of beta over 1 minus tan alpha tan beta. So tangent of alpha is 1/2. Tangent of beta is going to be -3/4. Over 1 minus tangent of alpha, which is 1/2 times -3/4. So this gives me 1/2 minus 3/4 over 1 plus 3/8. This should work out this way. So this is 11 over, let's see, sorry, that's the denominator. 1/2 minus 3/4 is -1/4 over 11 over 8. So tangent of alpha is 1/2. Tangent of beta is -4. Oh, that's where it's at. -4/3. I mixed them up. So -4/3. And this is going to be plus 2/3. So it's easy to make mistakes on here, so we just always got to watch ourselves. So 1/2 minus 4/3. So this becomes 3/6 minus 8/6, which is -5/6. And this is, so we have -5/6 divided by 5/3. So -5 over 6 times 3 over 5 gives me -1/2. So you see there that it's easier to run it using the sine alpha plus beta over cosine alpha plus beta if you already know them than to try and do this, because you could make mistakes. Some of these mistakes I made today were on purpose, some of them were not, and everything. So one shows you that they are possible cases where you can make mistakes, and that we got to just be careful. Step by step is the best way to do things.